Alright, well again, I can't get my weird little box here on the right to go away, but I am not going to mess with that. I had to log out and log back in earlier, but hope everybody's doing well. Sorry we're stuck inside on this beautiful afternoon. Well, maybe you're not inside, maybe you're outside. I'm stuck inside on this beautiful afternoon. Let me mention something that came up in the previous class, my 250 class, that I want to toss out here. If you have any feedback you want to share with me about the online aspect of this course, likes or dislikes or issues with Zoom, with microphone screen sharing, anything like that, send me an email and I will collect these, and if we can do something to improve this experience down the road, that would be great. Some of you are done after 2 more weeks, but if you're going to be around for summer, right, we're doing this online in summer. If you're here in fall, we're doing this at least in fall. And I'm not personally married to Zoom. I'm happy to go with Hangouts or Google Chat or Discord or Twitch or whatever is going to make the most sense, right? But I want to avoid having everybody have a different platform for each class, where they end up having to juggle 5 different platforms and 5 different logins and so on and so forth. And most people seem to be using Zoom at Clark, so that's the reason that I went with Zoom. But we can be flexible. All right, so any questions? We're gonna go back into networking after I make a few comments about SLPs, but any questions up front? So I posted a couple of things under SLPs. The final upload, the date for that is June 8th, okay, and it's due at 8 a.m. So June 8th is a Monday morning, so it's a week from this coming Monday. And all of this has been here since the beginning of time, so the basic setup for the report and so on is unchanged. Hopefully you've already looked at this, but if you haven't, or if you have questions, let me know. The main thing to know about this, this is a very complete formal report, okay? It's not like, 1 period objective to make a cool game, 2 alternative solutions, Minecraft and such, 3 solution specification, Unity, C, okay? That's not your final report, okay? That's maybe an outline for the key points to hit. I need to see a full report with a cover page with separate sections, preferably a table of contents. Typical successful SLP report is, 20, 30, 40, 50 pages. There's no page requirement for this, but if you're thinking, that this 1 page that you wrote qualifies for your SLP report, go back and look at the specifications, because it's probably missing some details, okay? And this should be a document that somebody who has never talked to you, has never heard about your SLP, can read this document and know what you did and how you did it, and why you did it, okay? So if you haven't already looked at this, please look at it. The main thing I want to point out here is the last section you want to hear is license terms. Make sure you specify in your written report whether you want this to be open access or restricted. If you want it to be open access, you can say something like this. If you want it to be restricted, you can say, do not distribute. You can use this for grading purposes only. This is confidential, right? And we'll treat it accordingly. All right. The other thing I posted was the SLP presentation. So this is, as usual, the last Tuesday of the quarter, so Tuesday, June 9th. SLP presentations will be done through uploaded videos. So we won't have face-to-face presentations, either physically or virtually. You'll make a video presentation and upload that to Canvas. Okay, and that's due by 5 p.m. on that last Tuesday of the term, June 9th. Basic guidance, right? Presentation, plan on 4 to 10 minutes in length. And it can be very conversational. Basically, imagine you're actually at the digital lounge doing your presentation. Someone comes up to you and says, hey, tell me about your SLP. What would you say to them? Okay, say it to the camera, upload a link. But you should cover at least the following topics, right? Project name, who the members of the group are, and then each person in the group should make one of the following statements. Okay, state your name, first name is fine, and say either I agree for this video to be publicly available, or I require that this video be used only for grading and not be publicly available. And make sure everybody in your group agrees on which of these they're going to say, okay, so that it's consistent. If you want this to be private and your group partner says, yeah, you can make it publicly available, and we make it publicly available, right, you're going to get upset when you find that. So coordinate this among the people in your group. And then, you know, the same stuff you would put in your poster. Tell us what problem you're trying to solve. Tell us your solution. And if you have a prototype or something working, even if it's not complete, demonstrate that for us. Describe your design, right, the key aspects of it, how you came up with your design decisions, and so on and so forth, and then talk about, you know, ideas for future development, future improvements, and so on. Okay, I'm going to strongly suggest you upload this to YouTube. You can mark it as unlisted, so that, you know, it's not publicly searchable, and you can send me a link to it. If you want to put it on a different platform, you can do that at your own risk. Okay. You'll upload a URL through Canvas, and I will go to that URL after the deadline, and I will try to look at your video, and you get one shot at this. And if I can't get to the video for some reason, I'm not going to give you any points. So, so stick with YouTube would be my recommendation, or be really sure that whatever you're doing makes the video accessible to me. Okay. And so those are the two SLP deliverables, right? 100 points, basically. The other comment I want to make is these deadlines are very rigid. Okay, it's due at 5 p.m. on the 9th. It closes at 5 p.m. on the 9th. And if you try to upload it at 5:01, don't send it to me in an email. Okay, upload it before the deadline. And if you want, you can upload draft versions of this. I'll take the latest one that's uploaded as of 5 p.m. Same with the report. While you're writing the report, it's the day before, upload what you have. And then if something happens and you don't get to upload the final copy, that's okay. I've still got the latest version you uploaded. It's the same drill we've been doing with Git all year long, right? Don't leave it to the last minute. Okay, this is going to be the last week of classes when this stuff is coming in. It's really difficult for me to take emails in Canvas, emails in Outlook, pull down attachments, rename them, organize them, put them in the same structure as the other ones, and so on and so forth. I'm not going to have time to do that. So upload it through Canvas by the deadline. Don't miss the deadline. Okay, I can't make it any plainer than that. And if you're unsure if you can get up in time to turn in an 8 a.m. deadline, right, turn it in the night before. All right, any questions on SLP? Presentations or upload videos or final reports? And just a reminder, each person turns in their own final report. If you want to turn in one video for the group, that's fine with me. If you want to turn in separate videos, that's fine too. But for the report, I want each person to turn in their own copy. All right, good to go then. Let's go back to talking about networking. So Wednesday we talked about basics of networking. We looked a little bit at TCP/IP and the old RFCs for those. We talked about ports, and we looked at different port numbers, 25 for Simple Mail Transfer Protocol, 21 for Telnet, and so on. 80 for unsecure web. So I want to add the details to these, and I want to look at how we do interactions across the network from Java. Okay, And Java makes things really, really nice. Okay, we can do this in C, right? And this was originally done in C. And when you get to a university, you'll do all this stuff in C, and you'll be setting up, individual bit fields and worrying about the byte order as you move from one machine to another, and all these gory details that are really fun to work through when you have time. But can kind of cloud the higher level concepts of like how exactly are we connecting two machines together. Java lets us just think about the high level concepts because we've got objects, right? And so we'll have classes that will encompass all of the details that we need to worry about inside methods we can just call. Okay, and using network connections is going to feel very much like writing to a file or reading from a file. Except instead of writing to a file, we'll be writing to a machine, on another part of the town, or another part of campus, or another continent. And instead of reading from a file, we'll be reading from, a distant machine. Alright, so all of this stuff is built on top of what's called a client-server model. So clients and servers. And we deal with client servers all the time. You've been dealing with them at least since you started 121. When you started connecting to the CTEC server. And then in 224 you started connecting to what I just call the Linux server, right? linuxengrcs.com. It's a machine running Linux somewhere. I have no idea where that machine actually is. But it's a machine running Linux, and it allows us to connect to it and log in. Okay, the server is running on that remote machine, CTEC Clark EDU, linuxengrcs.com. The client for you is typically PuTTY, or if you're on Linux, SSH, or if you're on your phone, whatever app you're using on your phone to log in to these remote machines. And almost everything we do on the web is client-server based. When you send a piece of mail, you have a mail program running that's called a client, and it's connecting to a mail server, which receives the message and the information in the header about who it's from, who it's to, and takes care of sending it out to another mail server on a destination machine. When you use Chrome or Firefox to access a web page, those things are clients. And they are connecting to a machine and talking to a program on that machine called a web server. And the web server on that machine takes connection requests, right, and says, oh, you want the page such and such, and it pulls that page out of its disk space and sends it to you. Or it fabricates it on the fly, right? So we use client-server stuff all the time, and even if we have multiple clients, everything is really one client to one server. So when you run a Minecraft server and somebody plays Minecraft and says connect to this server, right? Their Minecraft program they're running on their machine is a client. The server is the software that you're running on your machine. And the client connects to that and they talk back and forth. When another client tries to connect to the same server, right, it's a separate connection. It's initiated at the same server, but there's a separate connection there. And we'll break that down shortly and see how that works. So let's look at these two sides of the connection process. So what's the difference between the client and the server? The server must exist first. So you got to have the server running before a client can talk to it. If the client starts and the server doesn't exist yet, the client will get an error and exit typically. So the server must exist first, and this waits for a client. Okay, the client starts after the server, and it requests a connection with the server. So at this point, it's kind of, directional. You never have a client program running and a server starts to run and asks to make a connection to the client. Okay, that's not the way that this works. Client server, the server is sitting there first, waiting for a client, and then a client comes along and says, hey, I'd like to talk to you, server. Okay, this is how the connection is initiated. And it's very directional. Okay, that's going to be key in PA5. Alright, so server exists first, waits for a client, client starts running, requests a connection to the server. So how does the client request a connection to a particular server? Well, there's an address associated with every machine on the internet. So this is linux.engrcs.com. This is 192.168.0.20, right? There's an address, and the whole point of the IP packets that we looked at on Wednesday was we can say I want to send data from this address to that address. Okay. The server also has a port number associated with it. So the combination of address and port specifies a particular server. So the client requests a connection by saying, what's the address of the machine where the server is, and what's the port number of the server? Man, this is like my day for getting spam on my phone. Okay, so address and port number gives you a connection to a particular server. And then once the connection is established, you can have two-way communication. Okay, client can send to the server, server can send to the client, it can go back and forth in whatever order they choose based on the software. But the initiation looks like this. So servers are typically hanging out in the background, sitting around waiting for connections. So when I say SSH, I'm running a program called SSH, which is actually a client. And I'm making an SSH connection to this machine, linux.engrcs.com. And there's a program called SSHD, that's the SSH daemon. Daemon is a word that goes along with servers, right? SSH is the program I run to make the connection. That's the client version of this secure shell. SSHD is the daemon which is out there waiting for connections. That's the server version of this secure shell command. And this was started at boot time. So it's owned by a NIT, right? It's got a really low process number. And it creates other SSHD programs to accept logins. For example, this process 768 created a new process 9593, which is handling a connection with Nick. That's me. Alright, so client server. And those SSHD connections, those are listening on port 22. So if I do my Netstat command for looking at network status, ask for active connections associated with port 22, one of these is me. So when I logged in, I lost my logged in, but this is probably me, 7035.202.249. Nope, this is me. Alright, so that's my IP address, that's my port number. I connected to this IP address, that's the Linux machine, and this port number, that's the port that the SSH server is listening to. Alright, so we do this stuff already. Okay, let's look at how we do this in Java. So the basic setup is going to be the following. We're going to start the server, we're going to wait for our client, and then the client's going to make a connection request. Okay, so how is this going to happen on the server side? It's going to create something called a server socket. It's a Java class. So let's look at the documentation on that. Class ServerSocket. ServerSocket can be constructed with a port number. So when I construct an object of type ServerSocket and I pass an integer, one integer to the constructor, that's a port number. And it will create one of these sockets with this given port that'll wait for a connection. So let's play with this. So we need to have a java.net.serverSocket. So let's make a server socket. So constructing a server socket, all kinds of exceptions you can get. We can get an I/O exception, a security exception, an illegal argument exception. Okay, these ports can go from 0 to 65,535. So there's 16-bit integers, but 0 through 1023, maybe 1024 are reserved. You need to be a super user to create a port with one of those port numbers, because they're reserved for system processes like the mail daemon and SSH and the web server and so on and so forth. But above 1024, we can create any port numbers we want that aren't in use. So this is all going to have to go inside a try-catch block. So let's make a server socket. I'll just do port 1, 2, 3, 4. And I'll just do a catch-all catch block. And we'll just return if anything goes wrong. All right, so this should create a server socket for us. All right, so at this point, we have this socket. Okay, so what are these sockets that I keep talking about? All of this stuff, this connection between here is basically going to come down to, think of a pipe, where the middle of your pipe can be, you know, from one end of your desk to another, or it could be from your desk to a desk in Switzerland. All right, so this might, you know, go across great distances, but basically, once we have this connection established, there's something over here called a socket, and something over here called a socket that kind of looks like a file descriptor in C. It's something we can write into, and whatever we write comes out this end, and whatever is written in this end comes out that end. And the whole initiation of this connection is really about creating a pair of sockets that are connected to each other. Okay, that's what we're trying to do. Create a pair of sockets that are connected to each other across this network. All right, so once you have a socket, a server socket, we can call this method accept. And accept will listen for a connection to be made by a client. So we construct a server socket. To wait for a client, we say call the accept method on that server socket. And we'll hang out in the accept method until somebody requests a connection. Alright, so let's wait for a connection request. So when you get back from the accept call, what you have is a socket. Okay, this socket, which is returned by the call to accept, is going to be this socket. It's going to be on one end of a pipe that's connected to another socket that the client created. So I'm going to do the following. I'm going to make a socket. And we'll use this to talk with the client. So we'll import Java.net socket. Let's wait for a connection request. So sock equals ServerSocket.accept. So let's put some print messages here. Alright, so we'll accept a connection, and once we get that, I'll print out a message saying I got a connection request, and I'll print out the value of this socket, right, this thing that was returned by the accept method. Alright, so we'll compile that. Oh, I forgot to do another try catch, because the accept method can throw a bunch of exceptions also. So let's put this in the try catch block. So we'll just print out error accepting connection, see what that is in return. Alright, so this should be enough to get a server on the air. So what does it say? It says it's waiting for a connection request. Okay, we are sitting inside this call to accept. Right? As soon as we come out of this, we're either going to say error or we're going to say got a connection. So we're sitting inside this call. This is what it means when it says the method blocks until a connection is made. Okay, blocking method means you sit inside the call to that method until something happens that unblocks it. In this case, it gets unblocked once a connection is made. So let me open a different window. And let's just do a Netstat and see what's out there. And let's look for anything with a 1, 2, 3, 4 on it. And what do we find? There's a TCP socket out there listening on port 1, 2, 3, 4. Okay, that's this thing, this call to accept, is sitting there waiting for a connection request. Alright, so you remember the Telnet program, right? Telnet is an easy way to make connections to machines and to particular ports. So I can say Telnet, and I can say localhost, and localhost is a synonym for my current machine. So I don't know my IP address. Well, I do. It's 192.168.0.20, but I can also say localhost, and that'll mean my current machine. I could also say 127.0.0.1. That's also a synonym for my local machine. So I'll say localhost, and I'll ask to connect to port 1, 2, 3, 4, and watch what happens over here in our server code when I hit enter. It says, hey, I got a connection request. And it tells me that the socket was equal to, you know, a socket, and it came from address 127.0.0.1. and the port number was 43882, and the local port was 1234. What does that mean? It means that when I ran Telnet, which is a client, Telnet created a socket over here with this number, 43882, right, on this machine, my local machine, and connected to the server's port 1234. Sorry, 43882 is yeah. All right, so we've got a connection, but it exited as soon as it started, right? As soon as I hit enter, it said connected to localhost, and then it said connection closed by foreign host, right? Because what does our code do after accept? It exits. It says got a connection request, and then the program just exits. Well, when your program exits, the connection gets shut down, and so my Telnet program said, oh, the other host closed the connection, and then Telnet exited. But we got a connection going, right? That's key. That's huge. So we've got this pipe set up. Let's send some information across there. Well, it turns out if we want to read from a pipe from a socketed connection, we can use a scanner. There's lots of other things we can use, but a scanner will work perfectly well for what we're doing. So let me set up a scanner. So we'll import Java util scanner. And remember, scanners, we usually construct them either with system.in or from a file, right? So we're constructing scanners usually with a new file with the path name of a file. We can also construct a scanner from something called an input stream, okay? And what is an input stream? Well, it's all of this stuff, but we're not going to worry about that, okay? Because it turns out that when we have a socket, sockets come with a method called getInputStream. Alright, so here's the setup. We're going to have a socket. We're going to get an input stream. And we're going to use that to construct a scanner. Alright, so got a connection request. Let's set up a scanner to read from this socket. So I'll make a scanner object up here. So that's for reading from the socket. So I'm going to say SC equals new scanner. I'm going to use my socket sock.getInputStream. I'm going to use that to construct a scanner. And if anything goes wrong, we'll say error creating scanner and print an error message. And now let's just do our usual loop that we use for reading from a scanner. So while sc.hasNextLine, I'll set temp equal to sc.nextLine, and then I'll just print out the value of temp, and we'll just do that inside a while loop. Alright, good. Let's see what this does. So we'll come back to Telnet again. We'll make a Telnet connection to 1234. we get a message saying, hey, I got a connection. And now I can say, hello, this is a test. And when I hit enter in Telnet, it will send that out the socket. And watch, our server window over here says it received the following string. Hello, this is a test. And I can send whatever I want. I can send empty lines, I can send spaces, I can send funny characters. And to get out of Telnet, I do a control-right bracket, and that gives me options for doing different things. I'm just going to say Q for quit. And when I do that, my has next line returned false in my server, and so my server exited. And if I do a netstat for 1, 2, 3, 4, I can see a connection here that's trying to finish. It's a TCP connection. It's in a time wait state. It was initiated from port 44156, right? That's the port number that was reported up here. And it was made to port 1234. That's the server. And they're both 127.0.0.1, but if this was done between two machines, you'd see the IP addresses of those machines here. And that time wait will eventually go away. After about 30 seconds or a minute, this will disappear. It's basically waiting for the connection to shut down. And I can do things in here like close my scanner and close my socket and close my server socket to make this shut down more gracefully, but eventually it just times out. Alright, so we can send code from a client to a server, right? And we can do communication in the other way, because sockets also let us get output streams, and we can use that output stream to construct a PrintWriter. So let's try that. So we'll put a PrintWriter import, and up here when we construct a scanner to read from the socket, we'll also construct a PrintWriter socket. So I'll call it PW equals new PrintWriter. And we'll call sock.getOutputStream. And we'll say error creating scanner or PrintWriter. I'll make a PrintWriter object up here. And you've probably figured this out already, right? I could declare my PrintWriter down here if I wanted, and my scanner. I can't declare it inside the try-catch block because it's local, but I can declare things in the middle of my code, right? Sometimes that's a good thing to do. Sometimes it's better to declare them in the beginning, right? For where this code is going, I'm going to use these things throughout my code. So it probably makes sense to declare them up here, but like a temporary variable, or something I'm only using for the next 10 lines of code, nothing wrong as far as I'm concerned with declaring it where you're going to use it. All right, so let's do a print statement. Let's go ahead and write a message out to the server, to the client. So we've got our PrintWriter object. We'll just say PW print line, hello, I am the server. So compile that, run it, hop into our Telnet window. And we got the connection request, and I can send things, but I never got my message saying, hello, I am the server. Well, if I kill this off, right, my connection will go away. So, PrintWriters work fine for sending stuff to our display, right, or for writing things into files, but remember, we need to close them to actually get the stuff written out. Okay, remember I said if you don't close a PrintWriter, the stuff you've written to it may or may not actually appear in the file. And this has to do with buffering. So PrintWriters are considered kind of a high level, sort of a cooked version of output. When you say print line, print line, print line, you're not guaranteed those things are actually being printed right then. They're being queued up, they're being buffered for printing eventually, but PrintWriters like to print things all at once. So it's going to save a whole bunch of print requests and then print them at one time. We can circumvent that by saying flush. So we can force this print line to be sent right now. And that's going to make all the difference. So now if I make my telnet connection, I immediately get the message, hello, I am the server. All right, so let's do an echo. So let's print back to the server temp.to uppercase. So let's send back an uppercase echo of what the client sent us. So I can say this is a test, and I get back, oh, and what did I forget to do? I forgot to do my flush. Alright, so let's do our telnet. Hello, this is a test. And I get back the uppercase echo. Alright, this is 55 lines of code, but it's really only like 4 lines of code to set this up. Okay, try-catch blocks take a lot of space. We've got to declare variables and so on and so forth. But what did we really do? First, we created a server socket. In this case on port 1234. Then we said accept connections on that and give me a socket for the connection you accept. Then we said, let's construct a scanner to let us read from that socket, and let's construct a PrintWriter to let us write to that socket. And after that, we are completely set. Now it's just like we have a scanner we can read from, which will give us anything that's coming from here, a PrintWriter we can write to, which will send anything that we want to the other machine. And so this, you know, is like, you know, a typical loop we've been doing since week 1, reading from a scanner and writing to a PrintWriter. The flush is a bit of a new twist, but other than that, right, this is just doing the same thing as file I/O, but it's networked. Okay. Now it's not terribly exciting because, you know, this window is sitting on the same machine as this window, but they're separate processes, right? But if this was running on a different machine, right, I could telnet instead of localhost the IP address or the name of that machine, and I'd be talking to this machine across the network. Okay, you could try this using your network. You know, from your machine, you could try to telnet to the IP address of my machine, and if you could get a connection to me, you'd be able to, you know, send me messages using telnet. Now that won't work because of security, right? So my router will not pass your messages to this laptop that I'm running on. But I can set it up to do that. Okay, that's just something called port forwarding. And I can say, hey, anytime a message comes looking for port 1234, send it to 192.168.0.20. And if I do that, any of you could telnet to my actual IP address, 1234, and we could swap messages like this. Okay, that's a really fast, high-level overview of how we can set up these network connections in Java. Now, we've only done one aspect of this, which was setting up the server, right, to be able to talk to a client. And so far, we've been using Telnet for the client side. But on the client side, it's almost exactly the same thing. We basically construct a socket, and when we call the sockets constructor, we can specify an internet address and a port. So I would say, you know, quote localhost, right, and then 1234 for the port number. Okay, and that's all we need, right? And the host can be a string, and it'll figure it out. So we can put in the name of a host. I could say linux.engrcs.com, and so on, and it will connect these things together. And once we have a socket, again, we can, you know, get an input stream, turn it into a scanner, get an output stream, turn it into a PrintWriter, and then the client can read from its scanner right to its PrintWriter, and it will go into this side's PrintWriter or scanner. All right, so we've got the tools. That's the basic setup. We'll go through this again, you know, a few more times in different versions, but that's the essential setup. So tomorrow we will talk about PA5. PA5 is going to be a networked version of your DOTS game, okay? And it's going to take very little change to your existing DOTS program. It's going to be really adding another layer on top, so that sometimes the person clicks a mouse to make a move. Sometimes you're going to read XY coordinates from a socket and use that as a mouse click to manage another person's move. And then we're going to be able to run this DOTS game with two people connecting their DOTS games together across the internet, and you each click with your mouse and you can see the other person's moves and so on. So I'll post that assignment tonight as soon as I write it, and we'll talk about it tomorrow. I'll show you sample code and we'll dig into how we structure all this. Alright, so I got office hours at 3 if you have any last minute questions to talk about. Otherwise, finish up PA4, push it to Git, make sure I am a reporter, and enjoy the afternoon. I will see you next time. All right, thank you.